Hi, welcome to Learning Monkey. I am Raghu here. In this class, we do some practice examples on normal distribution. The concepts to do these examples were clearly discussed in our previous classes. These are just practice examples. So please watch our previous classes and come back here. The link for the playlist is provided in the description below. Coming to today's class, a sales tax officer has reported that the average sales of 500 businesses. He is going to deal with 500 businesses, and out of those 500 businesses that he is going to deal with, the average sales is given as rupees 36,000 with a standard deviation of 10,000. So this is what he identified from his real-time experience. Assuming sales are normally distributed, then we have to find the number of business as the sales of which are above 40,000. So number of businesses that are having the sales above 40,000. That is what you have to identify. If you identify the probability value, we can identify the number of businesses. So probability value above 40,000, that is what we have to identify. Second one is find the percentage of business which are likely in the range between 30,000 and 40,000. How many number of businesses are around 30 and in between 30 and 40,000? That is what we have to identify. So random variable x is given as 40,000. If you want to identify the probability values, we convert this into standard normal random variable, which is called it as z. Z is equal to x minus mu by sigma, 40,000 minus 36,000 by 1000, which is converted into 0.4. Means we have to go greater than 0.4. That is the probability you have to identify. So probability greater than 0.4 is given as a 0.5 minus probability of 0.4. Why this is? We already discussed in our previous examples when we discussed about finding the probability values in the standard normal distribution using the table, standard normal table. There we discussed why greater than 0.4 means this is the value you have to identify, greater than 0.4. So on the right hand side, which is the probability value of right hand side is 0.5. So 0.5 minus 0 to 0.4. If you subtract this area, we'll get greater than 0.4. This is the explanation given provided previously. So that is what we have to do. 0.5 minus probability of 0.4 from the table. So apply 0.4. You have to check the table and find the probability value. How to check the table? The table is provided in our previous classes. 0.5 minus 0.4. The probability of 0.4 is given as 0.1554, which is so finally we got 0.3446. Number of businesses is given as 500 multiplied by 0.3446, which is 172. Approximately 172 businesses are having the value, means the average sales are above 40,000. That is what our first question is. Second question is very simple. From now it's very simple. Probability of 3,000 less than x less than 40,000. Convert this into standard normal random variable. Z1 3,000 minus 36,000. It's not 3,000. 30,000 minus 36,000 by 10,000, which is minus 0.6. And Z2 we already calculated above 0.4 for 40,000. So probability of minus 0.6 is equal to probability of 0.6. So minus 0.6 means this side, both sides are equal, symmetric in shape. That's why probability from 0 to 0.6 is equal to probability from 0 to minus 0.6. So we can apply anything. That's why we are going to add both the things. So probability of 0.6 plus 0.4, because we have to identify this area and this area. Both addition, total area means addition. So 0 from the table we got that 0.6 is given as 0.1554 plus 0. So 0.4 is given as 0.1554 plus 0.6 is given as 0.2256. So addition of 0.3811, 38.11%. So 38.11% of the businesses are having the sales between 30,000 and 40,000. Now coming to the second question. Weights of 300 students are normally distributed with mean 68 kgs and standard deviation 3 kgs. How many students have weights greater than 72 kg? So greater than 72, which is very similar to our first question A bit. So greater than 72, random variable x is 72. We have to find the z is equal to n x minus mu by sigma. Z is equal to 72 minus 68 by 3, which is 1.33. Probability of z greater than 1.33 means we have to identify this. This can be given as 0.5 minus probability of 1.33. So 0.5 minus this probability value is given as 0.4082, which is 0.0918. This is the probability value. So this is how the basics which we covered in our last classes. Using that we have to identify the probability values. Hope you understand these examples. If you have any questions regarding the concepts, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.